Here is a fast and quick way to show that this summation, this double summation, is equal to n squared times n squared minus 1 divided by 6. To achieve this, let's just expand this summation very quickly. So to do that, this summation that we refer to as S, let's just say S is equal to double summation, and then we have j squared minus 2j times k plus k squared. And now we can expand this summation in this form. So we can say sigma sigma and then j squared, and then we have minus 2 sigma sigma jk, and then we have plus sigma sigma k squared. As you notice, effectively this and this one are the same. So one thing I can do is I can just simply say is 2 times sigma sigma j squared and minus 2 times sigma, and of course one of these is sigma from j from 1 to n, and the other one is, let me just write it in a better fashion. So the other one is, so this one is j, the other one is from index k 1 to n. So one of them completely depends on index k, the other one completely depends on index j. I can rewrite this double summation in this format: sigma j from 1 to n on j times sigma k from 1 to n times over k. All right, so I'm going to rely on two well-known summations. So this one, of course, one of them is j from 1 to n, the other one is k from 1 to n. As you can see, j2, which is the argument of summation, does not depend on k. So I can rewrite this one as sigma j1 to n, j squared outside, and then sigma k1 times sigma k1 to n1. And the other one, these two are the same. So I can say minus 2 times sigma j1 to n j and squared. Okay, so obviously this one is just simply n times adding 1 to itself, so it's n. And n times j squared, I can take n outside, so at the end, this turned out to be 2 times n sigma j from 1 to n j squared, and then minus 2. This is a well-known summation, which is, I'm going to write it again, but let's keep it as it is. So sigma j from 1 to n j squared. Okay, both of them are well-known summation, one of them being this one. Okay, so this one is a well-known summation that I have proven in a separate video. So this one is simply, let me just write it here. Okay, so this one is maybe over here. So sigma j from 1 to n j squared. In a separate video, I have proven that this one is n times n plus 1 times 2n plus 1 divided by 6. And this one is also a well-known summation, which is simply, we are saying it's sigma j from 1 to n on j is n times n plus 1 divided by 2. Okay, so I'm going to use these two guys and I'm going to substitute. So as a result, what I get is, let me change the color. What I get is 2 times n, and instead of this, I'm going to substitute from here. So it will be n squared effectively, because 2 times n becomes n squared, and then I have n plus 1 times 2n plus 1 divided by 6. Okay, and for this one, I'm going to substitute n times n plus 1 divided by 2 squared, so it becomes negative 2 n squared. Let me just make it cleaner. Okay, so what we have is n squared n plus 1 squared divided by 4. Now, if you simplify, we can just simply factor out n squared times n plus 1 from both of these components or terms. And as a result, what I get, 2 over 6 becomes 1 over 3, and then we only have 2n plus 1. So 2n plus 1 over 3, and then we have minus n plus 1 divided by 2. If you further simplify, you get exactly what is described here. So you will get n squared times n squared minus 1 divided by 6. And this this completes the proof here for this double summation.